My name is Frans Skarman, and I'm talking about a FPGA Raspberry Pi camera decoder thing that I've been playing around with for the past year. So first of all, a few things about me. There was a picture there, it's not loading for some reason. But I'm developing two projects. One is the Spade Horror description language, which is quite obscure, and the other one is a Surfer waveform viewer, which is a little bit less obscure at this point. So maybe you've heard of one of those. If you're looking for a good waveform viewer, have a look at Surfer. But I'm not talking about either of those projects directly today. Instead, I'm talking about something I started last summer, which is this thing. And it's a remote-controlled submersible thing, in this case built out of a bunch of PVC pipes, because I built it in a week and it's very janky. But it did work, and I was able to go into the ocean and take some videos of fishes, which was the start of this thing that I wanted to do. But the problem with this, it's a fixed camera with quite a low field of view that's pointing straight forward. And if there's something off to the side, you have to turn the whole sub around in order to see that. And that's not as fun. So what I wanted to do was have a way to look around. Of course, a simple solution is to put a servo and have the camera tilt, but that's not fun. So my idea now is to have several cameras, probably 3, pointing in different directions, and then stitch everything together in gateware, I guess. And well, it's a fun excuse for an FPGA project and to play around with cameras. So going back to the slides, the cameras I'm using are the Raspberry Pi cameras because they are easily available, quite cheap, quite easy to interface with. They talk something called CSI2, which is also used by a lot of phone cameras. So this protocol is quite general. It's not super hard. It's super easy to find documentation for it because it's proprietary, but you can find some sketchy PDFs. There's also some previous work here. So GateCat of NextBinAr fame has a Verilog library, which I drew a lot of inspiration from, especially with doing the weird analog stuff that you need to do here, or semi-analog. And there's a project by Circuit Valley, which seems to be a little bit more fancy, but it's also only for Xilinx FPGAs, as far as I can tell. So, of course, there are technical reasons for me not to use these. Not really. I just want something that's written in Spade. And to be fair, I tried porting GateCat's library over to the ECP5. Without understanding the protocol, I couldn't get that to work. So I started writing my own thing. Now, I could probably port that library to the ECP5, but now I have my own. So I want to show off a little bit of this code because I'm quite pleased with it. Why are my slides out of date? Okay, that's fine. So this protocol, I have a high-level description on the left and the code on the right. So this protocol starts off with several lanes of data. These are really serial data, but before this process, there's some Serges stuff that is too messy to put on a slide. So I didn't. But in this case, we have 2 lanes of bytes. But these are not actually bytes. They're unaligned, so we are not sure that with the start of the byte is on the start of each at the start of each thing we're receiving every clock cycle. So we need to align these, looking for start of transmissions, and that's done there. Once we've aligned them, we can take these 2 individual streams and merge them together into one single stream, which we can work on later. Once we have the single stream, we can look for packets in this stream by looking for the headers of the packets, and from the packet headers we can split the thing into short packets, which are things like this is the start of a new frame, this is the end of a new frame. I think there's some other stuff that the Pi camera doesn't send, and we can also go look for long packets, which contain the actual pixel data. So once we have the stream of long packets, we can look for pixel data by looking for packets with the header 0x2a, and in those packets, the rest of the stream will be raw pixel data that we can work with. So there's some Yosis stuff in here. Oh, I know why my slides are out of date. There's some Yosis stuff I wanted to briefly mention because this is, of course, the Yosis community meetup. So I'm using, actually, oh yeah, okay. I will need to live patch my slides. Hopefully that works. Reload. It does, yes. Okay, so YOSYS and XPNR stuff. So I'm using YOSYS, I'm using XPNR, I'm targeting the ECP5 board, the ULX3S in this case, with a camera in front. And it's basically just a normal YOSYS flow. I don't do anything special apart from something in XPNR, which is, I have quite high speed inputs, and those inputs are, I need those to get into the sort of clocked domain very fast, and they don't by default. So my solution to that was to do some basic floor planning and take everything that's done sort of asynchronously and put it very close to the input pins by just constraining those specific cells to the input pin or to an area close to the input pins, and that solved the weird issues I was seeing. It does work. I can also show you that it does work live, but it's kind of hard to, I don't think you'll see much here, but it does work. The picture is rotated 90 degrees because it's not because of the decoder, it's because the screen is in portrait mode and not landscape mode, and rotating an image is very, very difficult.
1 minute.
All right. Synthesis-wise, this thing is slightly faster and slightly smaller than GateCat's implementation, which I'm very proud of. It uses about 500 LUTs, so it could run on a very small ICE40 if you wanted, and runs quite fast. So yeah. If you want to learn more, I have a GitLab repo, and if you want to see me ramble about this project and everything else, you can follow me on Mastodon.